Okay, this video is to help you with the IXL lesson Factor Quadratics Special Cases. Okay, and since we're just briefly looking at some algebra topics, because Miss Bajarik's going to go a lot deeper with everything and explain things in a lot more detail, I'm just going to look at one special case in this lesson, okay? One special case. We have been only doing quadratics. We've only been factoring quadratics for the most part that have three parts. Okay, those are called trinomials. Okay, three. Tri means three. Okay, this lesson, the special case I want to look at is the quadratics that have only two parts. Okay, like x squared minus 25 down there. Okay, there's two parts. Okay, those are called binomials. Okay, bi means two. Okay, one way to get a binomial with multiplication is by starting out in the form a plus b, a minus b. Okay, I just mean two things that are the same, two sets of pieces that are the same, but there's a plus sign between one set and there's a subtraction sign in between the other. Now, if you may not have seen this on your learning path. Some of you have, some of you haven't. Okay, so just do the best you can. I think you'll catch on, even if it wasn't on your learning path. But when you multiply something like x minus 5, x plus 5, okay, using the FOIL method, okay, the middle term will go away. Okay, when you do multiply the first terms, x times x is x squared. The outside, positive 5 times x is positive 5x. The inside is negative 5 times x, which is negative 5x. Last would be negative 5 times 5, which is negative 25. And see, the middle terms cancel. Okay, you're going to be left with a two-part polynomial. Okay, it's called a binomial. Okay, so when I multiply x minus 5 times x plus 5, I end up with x squared minus 25. Okay, factoring is backwards. I'm starting with x squared minus 25, and I end up with x minus 5, x plus 5. Okay, so the big idea, the special type of problem I'm going to work with in this lesson is to factor a binomial, okay, a two-parter, something squared minus something squared. You want to rewrite it. I mean, this is the way I would do it. I would rewrite it as something squared minus something squared. And then I would take those two somethings and put a plus sign between them and a subtraction sign between them. Okay, I'll show you what I mean. Okay, let's say I wanted to factor k to the second minus 36. Okay, that's a two-parter. Okay, this is a binomial. What I'm going to do is I'm going to try to rewrite it as something squared minus something squared. So I need to think about what can I square to get k squared. Okay, that'd be 6. I'm sorry, that'd be k. That'd be k. What can I square to get 36? Okay, that'd be 6. So there's my form I'm thinking you should try to get to make this easier. So it's equal to k to the second minus 6 to the second. To factor it, just take that k and 6, put a plus between them, and put a subtraction sign between them. There's the factored form, k plus 6 times k minus 6. If you FOILed, okay, if you multiply that out, you will get k squared minus 36. Okay, another one, 144h squared minus 9. Okay, try to make it fit this pattern, something squared minus something squared. Okay, so what can you square to get 144? That'd be 12. What can you square to get h squared? H. Okay, see, if I take 12h times 12h, I'll get 144h squared. Okay, what can I square to get 9? 3. So my factored form would be taking the 12h and the 3, putting a plus sign between and a minus sign between. Okay. Now I will go ahead and go over this trinomial because they're going to throw in 2 more special cases. I don't want to go into the specifics of the other 2 special cases, but they involve trinomials that are going to end up giving you 2 factors that are exactly the same. Okay, I'm simplifying it, but I don't want to really get into the actual rules and stuff. I mean, you could if you wanted to. But let's say I wanted to factor 9m squared plus 6m plus 1. Okay, I'm going to use my trick that I use with trial and error. I'm going to take 9. I'm going to think of 9 as 3 times 3. Remember, I told you these are going to turn out to be doubles. Okay, they're going to be exactly the same. So I can just tell you it's going to be 3 times 3 to give me 9 instead of 9 times 1 or 1 times 9. Okay, think of 2 things that multiply together to give you 1. That'd be 1 times 1. Okay, I'm going to test it. 1 times 3 is 3. 3 times 1 is 3. Add those up. And yes, it is. It is 6. So this means my answer is 3m plus 1. The top row has a positive 3 and a positive 1. So that means 3m plus 1. And the bottom row has exactly the same. Positive 3 and a positive 1. So that's 3m plus 1. Okay, so my factored form is 3m plus 1 times 3m plus 1. Now, I believe on IXL, I mean, and just in general, if you are multiplying 2 things that are exactly the same, it looks a lot better if you use an exponent. So instead of saying the answer is 3m plus 1 times 3m plus 1, let's say it's 3m plus 1 squared. Okay? So there's the binomials that use that really easy rule. Just try to get something squared minus something squared. And I'm pretty sure that all the trinomials they throw into that lesson are going to give you only the ones that will give you doubles, the same exact factor twice. Just be sure to use the exponent of 2, okay, because it looks better. Okay, guys, let me know if you need anything.